Hello everyone. Today we're going to be looking at confidence intervals. So sample size and composition are important considerations when conducting or interpreting results of a survey. This is the main topic we'll be looking at here today with confidence intervals. Any credible survey generally reports this type of information, but there are a few other variables to consider as well, especially if you're trying to accurately gauge people's opinions. There's usually some level of uncertainty that can't be avoided unless we take a census of the entire population. But even then, there are several ways that a survey can go wrong. I'll just mention one before we move on. You might generally assume that all surveys are created equal, and that might often be a safe assumption as long as it's well made. There's one or several questions that try to figure out what people are thinking, and we collect some data. Pretty straightforward, right? Well, not exactly. Question quality is an important factor to consider that can impact the results of a survey as well. Consider this question. That is an example of a leading question. It is not at all neutral. Whoever wrote this question is likely trying to steer participants in a particular direction, and in this case there is no option for people to express any thoughts to the contrary. And we might see a headline such as this come out. Is there a better way to ask this type of question? This one might be a little better, but isn't entirely neutral either. Neither is this one. It's harder than you'd think to create a good quality question that asks what you think you're asking in a completely neutral way. Anyway, my point is that surveys can be misleading in many ways, and you do well to ask a few critical questions. Probably wise to take everything with a grain of salt. What's the credibility of the source? Are they entirely neutral? Would they be interested to see the result go one way or another? Maybe a company owned or supported by Pepsi is trying to determine soft drink preference, for example. Stay skeptical. It's good to have an open mind, but not so open that it falls out. Anyway, on with the rest. So we're going to read through example number 1 together, and I'm confident you can fill in the blanks. Feel free to pause the video at any moment if you need some time to work anything out. So a survey was conducted at Town School regarding the timetable. Out of 300 students surveyed, 82% wanted a change in the timetable. The results were accurate within 2 percentage points 19 times out of 20. So what does all of this mean? The margin of error for the result is plus or minus 2%. This means that between 80% and 84% of all students in the school will want a timetable change. The confidence level is 19 out of 20, or 95%. Therefore, if the survey was conducted 100 times, then 95 of those 100 would show that between 80 and 84% of the students would want a timetable change. The general statement would be the survey administrators are 95% confident that between 80 and 84% of students at Town School would like a timetable change. So a confidence interval is a statement that shows the range of the actual or true value of what is being measured. The confidence interval for the question regarding timetable change is 82% plus or minus 2%. If there are 2,000 students in the school, then determine the range of students that would like a timetable change. So for the lower end, we would use the lower percentage as a decimal, multiply that by the number of students, and that gives us a number of students on the low end. And for the upper end, we multiply the upper percentage as a decimal by the number of students, and we get an upper end on the number of students. As the size of the sample representing the population increases, the margin of error for the results decreases, and therefore the range in confidence interval also decreases. So moving on to example number 1, the mass of sugar packets ranges from 3.4 to 4.2 grams. Determine the margin of error and express it as a percent. So we can see 3.4 is here and 4.2 is here. The middle of this interval is at 3.8 because it's 0.4 grams to get to 4.2 and 0.4 grams to get to 3.4. So we could express the mass of a sugar packet as 3.8 plus or minus 0.4 grams. And if we wanted to do that as a percent, 0.4 grams out of 3.8 amounts to 10.5%. So we could also communicate 3.8 grams plus or minus 10.5%. In example number 2, we're looking at hockey pucks. So pucks in the NHL must be between 160 and 170 grams. One manufacturer produces pucks for the NHL and has more stringent specifications which are tested by measuring the masses of random sample groups of pucks. If the mean mass of the sample is between 163 and 167 grams, then the equipment is functioning properly. The confidence interval that is being used is from 163 grams to 167 grams. Next, we need to determine the margin of error for the mean mass of the hockey pucks and express it to the nearest hundredth of a percent. So the metaphorical distance between 163 and 167 grams can be determined like this. We go 167 minus 163, which is 4. And if we divide that result by 2, we get 2. So we could express the weight of the hockey pucks from this plant to be 165 plus or minus 2 grams, because 165 is in the middle. And as a percentage, we would go 2 divided by 165 times 100%, which works out to be 1.21%. Next, the confidence level that the manufacturer has for the mass of the pucks depends on sample size. The quality control engineer uses the following chart created by the company to determine the sample size. So if they're looking for a confidence level of 99%, they need a sample size of 120. For a confidence level of 95%, they need a sample size of 70. And for a confidence level of 90%, they need a sample size of 50. So starting from the top, based on a sample size of 120 pucks, the manufacturer is confident that 99 times out of 100, the mean mass of a hockey puck will be between 163 and 167 grams. Based on a sample size of 70 pucks, the manufacturer is confident that 95 times out of 100, the mean mass of a hockey puck will be between 163 and 167 grams. And based on a sample size of 50 pucks, the manufacturer is confident that 50 times out of 100, the mean mass of a hockey puck will be between 163 and 167 grams. The smaller the size of the sample, the less confident the manufacturer can be about the mass of hockey pucks that are made. For the manufacturer to be 98% confident that the mean mass of a hockey puck is between 163 and 167 grams, the quality control engineer would have to measure somewhere between 70 and 120 pucks. In example number 3, a cosmetic company advertises that 85% of users saw reduced visible lines with regular use of their anti-aging cream. The company states that the results of the poll are accurate within 2.5 percentage points 9 times out of 10. First, we need to state the confidence level and the margin of error. So if the poll is accurate 9 times out of 10, the confidence level is 90%, and the margin of error is given here, plus or minus 2.5%. Next, we need the confidence interval. So the actual number that was measured was 85%. That was the number of users that saw reduced visible lines. So we would have 85 plus or minus 2.5%. So if we subtract 2.5 from 85, we get 82.5% on the low end. And if we add 2.5% to 85, we get 87.5%. If 400 people use this cream, then determine the range of the number of people that will see reduced visible lines. So on the low end, we use this percentage as a decimal and multiply it by the number of people. So we go 0.825 times 400, which gives us a result of 330. And for the upper end, we use this percentage and multiply it as a decimal times 400. So we get 350. So we would expect to see between 330 and 350 people out of 400 to see reduced visible lines. So you can try these textbook questions out now. I'll need to see number 6 from you. That's it for me for today. See you next time.